So today we're looking at just a huge moment in the history of science. We've got sources here on the clash between Isaac Newton and Albert Einstein.
Yeah, but it's not really about two guys, is it? It's about a worldview, a kind of universal operating system that ran the world for 200 years.
And then just stopped working.
Exactly.
Yeah.
For 2 centuries, Newtonian physics wasn't just a theory. It was, for all intents and purposes, reality.
And that's our mission in this deep dive, to find the exact moment that reality started to crack. We're going to look at Newton's almost impossible genius and then the one tiny annoying mystery that broke everything.
And by the end, you'll see how a theory can be perfectly right and at the same time completely wrong.
Let's start with Newton. Reading about his miracle year is, well, it's kind of frustrating. By age 26, he's figured out the laws of optics, motion, gravity.
And, as a side project, he invents calculus, both integral and differential.
Right, just as a side project.
But the calculus is key,
Yeah.
Before him, math was mostly static, like a photograph. Newton gave us the mathematics of change, of movement.
But the really big idea, the one the sources all point to, is this concept of universality.
Yes, this is the paradigm shift. Before Newton, people thought there were two sets of rules, one for us down here on Earth,
Your things fall.
and another for the heavens, for the planets and stars moving in their perfect orbits. Newton he smashed them together.
He showed that the force pulling an apple down from a tree is the exact same force keeping the moon circling the Earth.
Precisely. One set of rules for the entire cosmos. And it just worked. It was flawless for generations.
Which brings us to its greatest triumph. The moment this confidence was, at its absolute peak, the discovery of Neptune in the 1800s.
Oh, this was the ultimate mic drop for Newtonian physics. It really was.
So astronomers are tracking Uranus, and its orbit is a little wobbly.
Right. It was speeding up and slowing down in ways the math said it shouldn't.
Yeah, you or I might think, maybe the math is wrong.
But they didn't. They were so confident in Newton that they assumed the math was right and the universe was wrong. Or at least that it was hiding something.
So they literally sat down with pen and paper and calculated where a hidden planet must be to cause that wobble.
They figured out its mass, its location, everything. A planet no human had ever seen.
And then a German observatory gets the coordinates, points a telescope at that exact spot in the sky,
And there it is, Neptune, within 1 degree of their prediction.
Wow.
I mean, think about that. They found a world with math before they saw it with their eyes. At that point, Newton's laws weren't a theory anymore. They were the master key to reality.
But of course, the celebration didn't last, because our sources then point to another problem planet, Mercury.
Right, the planet closest to the sun, its orbit was also off. Just a tiny bit. It was shifting in a way that didn't quite match the predictions. A much smaller error than Uranus, but it was there.
So they just pull out the Neptune playbook again, right?
Exactly. They thought, the math is perfect, there must be another invisible planet.
And they even gave it a name.
They did. They called it Vulcan, a little planet hiding in the sun's glare, tugging on Mercury.
And this is where the story completely changes. They spent decades searching for Vulcan.
I mean, they looked everywhere. During solar eclipses, with the most powerful telescopes they had,
And they found
nothing, because Vulcan wasn't there.
So with Uranus, the problem was a hidden object. But with Mercury, the problem was the theory itself.
That's the crack in the foundation. Newton's laws were breaking down in the extreme gravity so close to the sun. They were trying to fix a broken model by inventing a ghost.
And it took a young patent clerk, Albert Einstein, to finally say, maybe the problem isn't a missing planet.
Maybe the problem is our understanding of gravity itself. That gravity isn't a force, but a curve in the fabric of space and time.
So the failure to find Vulcan, that was really the end of Newton's universe.
It was, and it's such a powerful lesson, isn't it? The smartest people in the world preferred to invent a phantom planet rather than question the model they believed in.
They were so attached to their map, they ignored the territory.
It happens all the time.
And maybe that's the final thought for you to take away. Where in your own life are you hunting for a Vulcan, chasing an imaginary solution, just to avoid admitting that your own map of the world might need an update? Thanks for listening to this deep dive.